Assalamualaikum warahmatullahi wabarakatuh. My name is AMINUDDIN bin OMAR. We are going to present our group project, which is ergonomically optimized hand tools for enhanced usability and safety. This is our group member: AINUR HAQIM, Muhammad SYAFIUDDIN, SITI no IWANI, no Ani ZIKRI, and me. For introduction, current hand tools designs often prioritize functions over comfort and creating a problem for the user. This project focuses on redesigning the PVC pipe cutter, a tool that requiring significant force and repetitive movement by applying ergonomic principles to fit the tool to the worker. This project is mainly to optimize the design to minimize musculoskeletal disorders, MSDS, and repetitive strain injuries, which is RSIS, while enhancing overall usability. There are a few problems with the standard models. The first one is non-ergonomic handles. Straight or rigid handles do not fit natural hand curve, and users force into awkward postures, causing hand strain. The second one is poor grip design. Smooth materials become slippery, especially when wet, and users must access excessive gripping force to maintain stability. The last one is safety deficiency. Absence of locking system in many standard models is a problem because exposed blades pose injuries risk during storage and handling, and it can increase risk of hand-arm vibration syndrome, HAVS, and wrist strain. Our objective is to redesign and enhance user comfort through the ergonomic design, to integrate safety while prevent accident when using the hand tools, and to validate the ergonomic effectiveness of the proposed solution through the creation of detailed sketches and a 3D CAD model that demonstrates improved postures and significant force reduction.
Hi, Assalamualaikum and very good morning. My name is HAQIM. I will outline the methodology underlying our ergonomic pipe cutter redesign. Our work follows a structured user-centered pathway, like as you can see from the slide. We start from the problem identification and anthropometric data collection. From that, we develop conceptual design and material selection and design and task plan. We began with a systematic review of existing pipe cutters and observed 4 recurring issues, like insufficient grip under wet conditions, absence of a reliable locking mechanism, and excessive cutting force, and also non-neutral wrist posture. These findings establish the design requirement and inform every subsequent step in our process. Next, to ensure the tool fits a wide range of users, we applied anthropometric data such as grip span, thumb breadth, and handle length. This measurement guide ergonomic features like curved handles, rubber grip, and a thumb-operated lock. For durability and comfort, we select polypropylene with TPR for the handle, stainless steel for the blade, and lock, and silicone padding. And for the test plan, we validated the design through our 4 tests: comfort for performance, safety, and handling. Grip comfort ensure ergonomic design with a 4 out of 5 rating and minimal pressure points. Force measurement confirmed efficiency with a 15 to 25% reduction in cutting force. Locking reliability guarantees safety with 98% success and 0 accidental outlocks. Finally, slip resistant under wet conditions ensure secure grip with no visible slip. If any target isn't met, we refine and retest, delivering a safer, more comfortable, user-ready cutter. So I think that's all from me. Thank you.
From the reference on internet, we have several dimensions need to collect, from altometric measurement of studio BMID and BMIW. From that we have for measurement, which is hand length as handle length, hand breadth as handle clearance width, index finger as finger length, thumb breadth as thumb placement at handle, and distance between thumb and finger as grip span for at cutter features. For grip span, the dimension is 15 mm, which is 5th percentile. Small hand can fully close the handle to cut the part. For handle length is 200 mm, which is 95 percentile, which is shorter handle that support the palm for leverance. For finger length 140 mm, 5th percentile, the small hand user can reach cutter mechanism. And for thumb breadth is for thumb placement 10 mm, 5th percentile. Ensure knob of self-locking mechanism can be pressed comfortable. And for clearance width is 80 mm, 55 percentile. Handle must be narrow enough to avoid crushing but still comfortable. Next, I will explain the design and concept based on ergonomic principle. Here, I provide the hand sketching and 3D rendering. First, the curved handle was designed using ergonomic data to follow the natural posture, which is 45 degrees of human hand. This helps maintain a natural wrist posture, improve grip comfort, and reduce hand fatigue during use. Second, the rubber grip is added to increase friction and prevent slip. From a biomechanical perspective, this reduces the amount of force required to hold the handle, while ergonomically improving comfort and minimizing pressure on the hand during repetitive tasks. Lastly, the lock mechanism is designed to enhance feature, safety, and ease of use. It reduces the need for continuous gripping force, which help minimize muscle strain. Overall, these design features ensure better comfort, safety, and efficiency for a wide range of users.
This slide shows the discussion and analysis of the Redesign pipe cutter. The design is meant to fit a wide range of users by using anthropometric data. The handle's grip is based on the 5th percentile, so users with a small hand can close it easily and reduce hand strain. The thumb area and finger reach are also designed for small hands, making the tools easier and safer to use. At the same time, the 95 percentile hand width and hand length are used to provide enough space for knuckles and better handle supports. Overall, employing anthropometric data improves ergonomic comfort and safety. It is recommended to maintain this measurement to reduce fatigue and achieve a more ergonomic and innovative pipe cutter design. This slide presents the proposed solution and recommendation for improving the pipe cutter design. First, the original pipe cutter is not ergonomic and may cause discomfort during use. To address this, the cutter is redesigned with an ergonomic shape that supports a natural hand posture. This allows users to apply force more easily and reduce hand strain, especially during repeated use. Second, the handles can become slippery when wet, which affect grip control and safety. Rubber grips or cushion padding are added to handles to improve grip, increase comfort, and prevent slipping. Finally, the pipe cutter does not have a locking mechanism, which can be dangerous due to an exposed blade. A locking system is added to keep the cutter closed when not in use, improving safety and storage. Overall, this solution makes the pipe cutter more ergonomic, comfortable, and safer to use.
Assalamualaikum warahmatullahi wabarakatuh. My name is ZIKRI BMID3553, and right now I will present about our conclusion. To conclude our presentation, I will summarize the core focus of our project. Our primary goal was the ergonomic redesign of a PVC pipe cutter. At the start of this project, we identified that standard models in the market suffered from critical flaws, uncomfortable handle shapes, slippery surface, and the complete lack of a safety locking mechanism. To solve this, we adopted a strict user-centered design approach. We utilized anthropometric data ranging from the 5th to the 95th percentile to generate a 3D CAD model that would theoretically fit almost any worker. Our proposed design introduced 3 key features. First, we replaced straight handles with curved pump conforming handles. This design geometry forced the user's wrist into a neutral, natural posture. Second, to address the slippery issue, our material selection includes rubberized micro-texture grip zones to enhance friction. And finally, we integrate a thumb-operable locking mechanism into the assembly, ensuring the blade is safely secured during storage. Moving on to validation, since we are proposing a new design, we verified our design specifications against specific anthropometric dimensions to ensure inclusivity. For example, our design features a 50mm grip span into the closed position. We selected this dimension specifically because it matched the 5th percentile data, ensuring that users with smaller hand can fully close the handles without overextending their thumb. Conversely, we designed the handle with a 200mm length. This specification caters to the 95th percentile, ensuring the handle passes through the full width of a larger pump for maximum leverage. Functionally, our analysis indicates that this new geometry will eliminate the high pinch force required by traditional cutters. Through biomechanical optimization, the proposed high friction surface and pump support are designed to allow users to maintain a secure grip with significantly less static effort than current market model. Finally, I want to discuss the significance and broader impact of this work. This design proposal serves as a direct intervention into occupational health. The flaws we identified in existing tools are known cause of health risk. Our redesign is engineered to mitigate the risk of musculoskeletal disorders or MSD and repetitive strain injuries. We achieve this through specific engineering choice. By rebalancing the mass in our CAD model, we reduce the projected torque load on the user's wrist. By designing for knuckle clearance, we prevent the impact injuries that occur when handles snapshot. In conclusion, this project demonstrates that rigorous ergonomic analysis is a vital intervention. Our design shows that by prioritizing the user's body in the engineering phase, we can theoretically ensure better occupational health, safety, and sustained productivity in the industrial environment. Thank you for listening about our presentation. Thank you.